Hello and welcome to Autodesk Revit MEP 2012. My name is Tom Cassell. I'm an MEP Technical Specialist with MicroCAD Training and Consulting, and today's presentation is focused on transitioning HVAC discipline into Revit. The goal here is to give an introduction to exactly how Revit is beneficial to the HVAC discipline and in what ways it can speed up your existing processes, as well as coordination between HVAC and other disciplines, and even how to create construction documents using Revit. I would like to start with talking about how Revit differs than CAD and other CAD applications. Revit is not vector driven. In other words, these are not lines, arcs, and circles that you're seeing on the screen at the moment. It's an object-based program. In other words, when I need duct, I'm going to create a physical object that Revit recognizes as duct. Also, Revit's database driven. So being database driven, when we create duct, what's really happening is it's taking all that information about that duct and it's adding it to the database. For example, this 48 by 14 inch duct is in the database. The database knows that it's at 10-foot 7-inch elevation. It knows the hydraulic diameter. It knows the area. All this information, including the length, is included in the database. And what that's going to do is it's going to make some of the features that I show later much more powerful, such as schedules, sections, and elevations. Another difference with Revit is it's not a fake 3D program, and what I mean by that is we're not designing a first floor, a second floor, a third floor. We're actually working on a full 3D model. So here, we'll show the whole building right now. So I have an architectural file that was made in Revit Architecture, and we actually work within a complete model in a single file. Now that adds a lot more power to Revit. No more XREFs. I don't need to link files together in order to get all the information in one spot. All the information is already in one spot, which again is going to make the database even more powerful. It's also going to make things easier, such as running any chases that are going to cross multiple floors, connecting to any rooftop units that may exist, or just simply running floor-to-floor duct runs that may span one floor, rise to the next, and run again. I don't need to open up two different drawings, XREF them together, make sure everything lines up. How many times have you had a drawing where you've had to shift the duct on the second floor because it runs into something, but you never checked and coordinated that with the first floor or the third floor because it involves a lot of work of XREFing multiple files together and double checking a lot of work. Minor changes like that can cause major conflicts in the field. So Revit helps to alleviate that. Because Revit's database driven as well, all of that information stored on multiple floors gets consolidated in a single schedule, which I'll come back and talk more about later. But as you can see, this is a grand total count of all diffusers that are currently in this project. And this number will grow as we add more diffusers to multiple floors. Again, no need to XREF multiple files together in order to get full accurate counts as you would in AutoCAD MEP. Okay, now that we have talked a little bit about what Revit can do and how it works, let's focus on the actual drafting aspects of it and how it'll work laying out an HVAC system and laying out duct. You'll see that in 2D view it's not much different than AutoCAD. It's actually much quicker though. So in AutoCAD you do things like place blocks, or in other CAD systems you'll place blocks. In Revit you just place equipment. Minor difference. The big difference between Revit and AutoCAD is the fact that you now have to worry about one extra thing, and that's a 3D value. A lot of people think that I don't need 3D. 3D is just going to get in the way. It takes too long. None of that's true. You're going to find that 3D, as we mentioned earlier, is going to help with your coordination, and it really only takes one extra field to fill out, such as a 10 foot 7 inch elevation, and then place the block. So in AutoCAD, that was one more field I had to do other than AutoCAD, and now I have accurate 3D model. I can take this, run it, connect it into the main branch, and now I'm prepared to start laying out the blocks for my room. Now, all the diffusers are out in my drawing are blocks. So I'm going to go up top, I'm going to say air terminal. I'm going to come down and say, you know what? I'd like a 24 by 24 with a 8-inch round neck air terminal. Now that air terminal is going to be at an 8-foot elevation, and I don't want to see my flow arrows, not for this room. The other information that you can fill out, you don't have to, but you can. It's things like the flow. Now maybe I don't know the flow for right now, so leave it at 500. We'll see later that it's just as easy to fill out after the fact. And all I do now is I go out to the drawing area, I place all my diffusers, and then I put them in the wrong spot. So to move them, a lot like AutoCAD, move, there you go. They're all exactly in place right where I want them. I realize, you know what, these really are going to shift over. Hit move, snap, snap. Again, no different than AutoCAD. When I go to create the duct, it's just a matter of doing things like saying, what type of duct do I want to create? You know, I really want galvanized round duct, and I really am going to need 14-inch round duct coming off this unit. It's just a guess for the moment, but it's what we'll use. So there's some 14-inch round duct coming in off that unit. It's going to run all the way down. And right here I'm going to branch off and take a corner. Now, AutoCAD, a lot of trimming going on here. I have to put in a new block for an elbow. I have to make sure the elbow aligns. Revit does that automatically. I can take this elbow at this point, just hit the plus arrow, and now convert that elbow into a T. Now that's the T that I chose to use. If I wanted a different type of T, I could load a different type of T. Take it, do a branch off in the other direction. You know what, we're actually going to have 12-inch duct coming off of each side here, so I'm going to go 12-inch there, 12-inch there, and we're going to finish this system off with flex duct. So I'm going to run out my flex duct, connect to my unit, and there you go. We have completed the connections required for this. All right, what you're noticing that it's doing on this last duct is I ran 14-inch duct at the end. So Revit's instantly seeing that, hey, in order for this to work, you need a reducer. So it's automatically putting a reducer in for me, so that way this duct works. Well, I'm going to say, you know what? This was actually supposed to be 12-inch duct anyway, so I have to shrink that. Smart enough to take the reducer and move it to the T. Well, actually, I want the reducer here coming into the T. I'm going to make that a 12-inch T. There's the reducer there. And then there's a lot more options, such as I could have a reducing T. I just don't have one put in right now. So that way the T would accept the 16-inch coming in, and then it would allow 12-inch going out. So we now have a complete closed system. Here's some interesting facts about this complete closed system. I'm going to tell the flow of each one of these diffusers that it's 375. Well, if I have 4 diffusers, what happens at the VAV unit automatically is it takes 375, multiplies it times all 4 diffusers, and it figures out that this VAV unit is going to require an airflow of 1500. I didn't need to fill that out. That wasn't there automatically. If somebody comes back to me later and says 1500 is overkill for this room, I can take all 4 diffusers, go back and say, you know, it really only needs about 300 per diffuser. What's going to happen back at that VAV unit is that VAV unit now knows, oh, well then I only need to put out 1200 CFM. Therefore, it's only going to require 240 CFM from the main trunk. Well, this is going to go all the way back to the main air handling unit, and the main air handling unit now is going to know how much CFM is going to be required to supply the whole building. So in the long run, you're instantly going to be able to size your air handling unit based on the requirements for each room. It's going to be really, really fast. So a lot of painful calculations that usually have to be done by hand are now going to be done automatically. Changing views now to look at this in a floor plan view, what we'll see is just a slightly different information now that's being shown. We know that the VAV unit can calculate the total airflow required based on the air terminals that are put into it. If we check the duct though, the duct also knows that, hey, this piece of duct requires a flow of 300 CFM. It knows the size of that duct is 12-inch duct and therefore has a velocity of 382 feet per minute, has friction, pressure drop, velocity pressure, and even Reynolds number. All that information is automatically calculated by Revit. Now that includes the main run. The main run of duct requires 1200 CFM, therefore it has a velocity of 859 feet per minute. I can take this entire system, I can select the entire system, and actually I can just do it with a window. Take that entire system, get rid of the sprinkler heads that are in here, and up on the ribbon I have options for adding insulation and lining or even doing an automatic duct pipe sizing. So I can click automatic duct pipe sizing and I can size my duct based on the friction that's required, the static regain, the equal friction, or even the velocity that I want in this duct. So you know what? I want a velocity in this duct of about 800 feet per minute, no more. So what it's going to do is it's going to resize all my duct based on a maximum velocity of 800 feet per minute. In other words, it calculates this needs 9-inch duct. Now when I do that and tell it to calculate, I get options for calculating, such as use even sizes only. I can even control what pipe size, what duct sizes are available, restrict height, larger of connector, so when it connects to a VAV unit or to a diffuser and air terminal, it'll match the size on that air terminal. That ever common 9-inch size duct that you don't usually use, I can now take that and adjust it and make it 10-inch duct. So you aren't restricted, but the duct pipe size calculator is going to help speed things up quite a bit. Now if you want to resize your duct as it goes, so you know right around here we can actually reduce the size of the duct for the rest of this run. I can take this duct and simply split it. Say, you know what, I want to split it right here. I want to take this new piece of duct and I want to do a duct pipe sizing on this new piece of duct with a velocity of 800 feet per minute, and it'll resize just that one piece. So you don't need to redo an entire run. You can actually size one piece at a time. There's more to this as well. We can get more information out of the model than what you've already seen, and it's really where a model becomes a lot more powerful than a 2D file. Now what I can do with this is I have the ability to go and drop in a space into this area, and what a space is going to do is it's going to fill this whole room, and it's going to maintain information such as this room has a 9-foot height or an 8-foot height from floor to ceiling. So it's going to know now basic room information such as area, perimeter, volume, which is required in order to do a heating and cooling load calculation on this building, which will be covered in another video. But we have information down here that we can fill out, such as designed heating load, designed cooling load, but all the way up top you notice it'll actually notice and recognize things like actual supply airflow. So based on the 4 diffusers that I've put into this room, it's calculating that the actual supply airflow for this room is 1200. Again, this information is going to come into play later on when we get to this part where we're going to schedule and 3D aspects of this building as well. Up top, you'll notice some other miscellaneous information that doesn't apply to HVAC. It knows things like the average estimated illumination for this room. It even knows the actual lighting load for this room and actual power load for this room based on what electrical is already done for this room. So spaces are going to be beneficial as well. We can use this 3D model, though, to get more information 3D wise. So this is really where the 3D aspect of Revit becomes beneficial. I want to actually take a look at this and make sure it works, make sure it doesn't collide with any lights, make sure there's no piping running in this area. So Revit gives us the ability to quickly cut sections. Now I just have my sections turned off, so I'll turn them on real quick. You'll see that I just cut a section through this building, which is cutting the full length of the building. I just really want to see this room. So it's very dynamic, easy to control. You just stretch it to where you want to see. I don't really want to see the hallway. Just want to see this area right here. And I can go look at that section. Now that section is live and it shows me the whole building. Now I'm only focused on the first floor, so let's show the first floor and take a good look at what we just drew. So this is what we just drew, and I'm looking, yeah, I'm a little close to that light, but is that a collision? I don't know. I might be okay with it. You see some sprinkler heads in here, and if there was piping or fire protection running through this area, if there was plumbing running through this area, you could see all those pipes and you could visually check for any collisions. Now let's assume for just a moment there was going to be a collision or a problem here. Revit's most powerful tool is the fact that your 3D views, such as your sections and elevations, are completely live. In other words, at this point, if I realize, you know what, there's a pipe right here, I'm going to have to take my duct run and move it up just a little and level it off there. I can take it, split it, get rid of that middle piece, and just take this and say, you know what, we're really going to have to run it up about a foot higher, maybe a foot and a half higher. There we go. Well, that might be too much, so we'll go 26.6. There we go. I want to now reconnect these. Now in plan view, this is difficult to do. It's hard to adjust elevations while you're looking down. However, in section, you're going to find that this is very easy. I can go and make sure that I get a 45-degree elbow. Or rather, let's go with a 30-degree elbow. It's telling me a 45-degree elbow won't fit. So that's also useful information. At the radius I used, it won't fit. So I can go with a 30-degree, level off at 30, straighten out. Again, everything cleans up. Now, that pipe might be over here more. I get the ability to take this and stretch it over as far as I need to, stretch it as close as I need to. So I can do anything I want with this. I can even make elevation changes, say to 12 feet, and you'll see it'll readjust the sloped duct. Now let's see what that did to us in plan. Back in plan, it added the elbows for us, and it shows the transition. I didn't need to worry about doing this. So you make a change in plan and it affects your elevations. You make a change in elevation, it affects your plans. So it really is a better design option than AutoCAD is in that sense as well. So we can get more accurate 3D models. Because we've added all this smart content now, we've added diffusers, we've added VAV units, we've added duct, and it's all automatically added to the database. What we have the ability to do now is go create or look at schedules. For example, I have a room airflow schedule that is going to show me all the different rooms and spaces that have been created in this building, as well as the required airflow for that room and the area of that room. So it automatically knows the area of that room because it picked up the 4 walls, 5, 6 walls that border that room, and it knows the airflow that we've supplied to that room. So this is the space that I just created. I didn't give it a number yet. It actually belongs to the first floor, so it would end up being 101. This is conference room 6. and I haven't assigned it to a zone yet, but it knows that I put 1200 CFM worth of airflow in there because the 4 diffusers. It knows the area, and therefore I have a 1.4 CFM per square foot ratio for that room. Now I can decide if that's acceptable. I have this schedule pre-set up to show me that, you know, for conference room 3 down in the basement, I haven't assigned any airflow. So this can be used as a great check to make sure that throughout the building I've actually laid out all the diffusers I meant to lay out. And because all of this is automatic, if I go check my air terminal schedule that I've created, I now know that my air terminal count schedule that I had opened earlier is accurate, because this is reading from the model in order to count how many diffusers I've actually put into this model. So I've put in 74 type C diffusers, which are McQuay diffusers, and have a min and a max flow for CFM. Now I want to take this schedule, and you know what? I know what the minimum is, I know what the maximum is, but what's the average airflow for each of these diffusers? You get full control over doing things like adding assembly code, flow information, system abbreviation, system class, so I can tell if it's a supply diffuser or a return diffuser. So this would actually be called actual flow. So now I can look and say, here's the actual flow in all these diffusers. Here's the min and the max flow. So I can tell you that if I have an actual flow on 6 of these diffusers of 375 CFM, then I did not choose a diffuser that is the right size. These are going to have to be a different diffuser, such as a type F diffuser, in order to support that flow. You also get full control over these schedules on how they sort. So I can say, you know what, sort by flow, sort by type mark, sort by max flow, or don't sort at all. And if I say don't sort at all, it'll show you every single diffuser one by one that's been put into this schedule. It's really completely customizable on what you want to see out of these schedules. Okay. Making a few more changes just so you can see different scenarios. So here's all different ways that this diffuser can be laid out, including more fields that can be added to the schedule and updated again to show what you want the way you want to see it. Another benefit to working in 3D is the ability to check for collisions. Now we showed a little earlier that we can visually check for collisions using sections and other tools that are available, but there are tools built in, and this is one of the largest benefits to working in 3D. You start getting a much more complex model put into your building, and things start getting, a little complicated, as you can see. It's a lot of information contained in here, a lot of pipes running in different areas, a lot of duct, a lot of lights, a lot of air terminals. And it's very important for you to understand ahead of time if there's going to be a conflict in the field. By the time the construction workers have found that there's an issue, it's much more costly at that point for them to stop, put things on hold, make adjustments, submit an RFI, and then wait for that reply. So we can find out ahead of time if there's going to be a conflict. The way we do that in Revit is we use a tool called interference check, and I can run an interference check on any object that happens to be in this model. So I can do maybe air terminals versus light fixtures. So I want to know if I accidentally placed any of my air terminals on lights. Now if I do this and I say okay, no, there were none. Well, let's do another one that I think we might run into some problems with. So I want to know if any duct in this file has hit any pipe. I say okay, and it comes up and says yes. There was actually one scenario where duct hit pipe. And if I click, you'll notice it'll highlight the duct. Now the problem in this view is I have the pipe shut off. So I can't see the pipe, but I can see the duct. Well, let's turn on the pipe and we'll take a look at what might be colliding. Nope, we do have it turned on. There it is. So let's hit show. What it'll do is it'll zoom me to that pipe. Let's go to a fine detail view. So there it is. Yep, we have pipe that's going to hit that duct. Now that's a pretty tight area, so there's not a lot of room for moving the duct or moving the pipe, but we can now at this point select those objects and make adjustments. Now, if you're simply responsible for the HVAC, this might not be something that you can resolve. Your duct might not be able to move. You might not have enough room to move it. In this case, the pipe might be a lot easier to move, but you may need to submit that to someone else for them to make an adjustment. So at this point, we can take this and export this so we can send it out as an HTML file so we can report this. We can take a screen capture of the screen showing the collision and ask the piping engineer or the piping contractor to make an adjustment here as well. So if there were 200 collisions, this is going to save a lot of RFIs and a lot of time on the back end of a project. When you think a project's done and under construction and you've taken a project team and moved them on to the next project, it's a lot of work, and it's usually a hassle for them to have to come back onto the project and re-pick up what's going on, find the issues, make new sheets, and print it all out for review. So this here is going to be a huge time saver, and it's probably the #1 reason why people do migrate to 3D BIM technology. The last piece of information that I'd like to show with Revit involves printing in construction documents. Now, Revit is completely capable of carrying a project from the beginning to the end, not just for the floor plans, for the fire protection and HVAC and other disciplines, but also your sections and elevations. It can handle detailing as well, so it does 2D work. But it also handles printing, and it has an area down here where I can go and create sheets. So it's sort of like paper space in AutoCAD, where I can go through and say, you know what, this is not the Autodesk Conference Center anymore. This is going to be the elementary school for Bristol. Okay. The owner of this project is going to be MicroCAD, and this is going to be the first floor HVAC plan. All this information is really easy to fill out. It's just a matter of typing in different numbers, different dates, different author. All this information is completely editable and very quick. To put the first floor HVAC plan on the drawing, it's all drag and drop friendly. Now everything gets dragged and dropped and placed, but the size of the building is based on scale. So the scale of my view. Now my view is set at a scale of an 1/8 inch equals a foot. I can change that to hidden line view. I can change it to 1/16 inch equals a foot, 3/32. And when you do, what happens instantly is the sheet updates. I can take it and put it back at an 1/8, and you'll notice it re-updates. So this part's going to be real automatic. Now I don't really care about this east area because it's not part of my responsibility, so I get the ability to do stuff like activate the view, add a crop boundary, and crop out the areas that aren't of concern, which again is going to make it fit the sheet a little better. So now I can just go through and get out of that view, deactivate view, slide it so it sits a little nicer, and move on. Now we're ready to create a second sheet. Go ahead and say new sheet. The second one will be for the second floor. I'll go through and do the exact same thing. Now it automatically knows that MicroCAD is the owner of this project. It automatically knows that this is the elementary school for Bristol. The only thing it doesn't know is that this is going to be the second floor HVAC plan, or this is going to be mechanical schedules. Okay. And mechanical schedules are M6.1. Say that's my category for mechanical schedules. So all that information, again, just click and enter. Not much different than using attributes in AutoCAD, however they're much easier. Put my air terminal schedule on, it's just drag and drop. It comes in formatted the exact way you saw it before. might need to make some minor adjustments, but when you do, it automatically corrects itself. I hope you enjoyed what Revit MEP can do for the HVAC discipline. I want you to understand that this is just a glimpse of what Revit can really do, and each company would have different requirements as far as how Revit can really help them. So if I didn't address a specific question or a specific problem that you may have in your transition to Revit, or an issue that you may run into while transitioning to Revit, I'd be happy to answer any questions that you have, and I look forward to hearing from you. So feel free to contact us at MicroCAD Training and Consulting, and we'd be happy to set up a more personalized presentation just for you and your company. Thank you very much and have a great day.